So that was my slightly weird introduction to buttons. What we had was a box. I put in a giant red button. We'll talk more about buttons in a minute. That's connected to that tiny blue box I put in there. That's a relay, which in turn is connected to this device, which is an electromagnet. An electromagnet takes electricity, sort of as the name implies. When you have electricity flowing to it, it becomes a magnet. When I press this button, that relay will cause the electricity to stop in that electromagnet, and my key drops. When the button is no longer pressed, the electricity is returned, and if I can get disconnected, the magnet's not that powerful. There we go, my keys are connected back up. Here's another device which has a button. This button is connected to something slightly more powerful than an Arduino Uno. It's connected to a Raspberry Pi, so it's not that much more powerful. And when you press the button, I don't have electricity applied to it just now, you can ask it a question. So you can ask it, hey, what's the weather? Sort of like a Google Home, and it has a speaker built in. So it connects to the web. So let's take a look at buttons and see how they work. Okay, and here's my primitive attempt at explaining a button. And so when a button is not pressed, it's up here. Let me kind of illustrate that by turning it, right? And when I press it down, it makes contact. That's all a button is. You press on the button and it makes contact. So that's a very simple idea, right? You just have an on and off. It's a very simple mechanical device. But combined with a microprocessor, we can do pretty interesting things. So we have a TV remote, and I press the power button on the TV remote. So that sends an infrared signal, a Morse code signal, to identify which of the many buttons is pressed. And the TV has a microprocessor, a computer, that can interpret what to do. So the first time we press this button, it'll turn the TV on, but when we press it again, it does something completely different, right? It turns the TV off. So the TV has to remember in a way, when it hits a button, well, what should I do? Should I turn it on or off? Or the source button, the same thing. Netflix button. So all these are interpreted differently by the microprocessor in the TV. And we're going to look at very simple examples. So when we turn this on, we want the LED to do more than just turn on. Perhaps we want it to blink. Can't do that with a button. When the button's pressed, we'll need our microprocessor, our Arduino Uno. So let's see how we can do that and accomplish that task. Okay, so these are the buttons from the kit. This one I put a cool top on, but other than that, it's the same button. And there's a specific orientation to these buttons. So when you see the long part of the leg, that's the correct side. And when you press the button, this leg here will be connected to this leg. When you press the button in this case, this leg will not be connected to this leg. So keep in mind that you're trying to connect, you'll see the full legs here, the full silver, and you need to have a wire connected to this leg and this leg. Sometimes attaching the button to the breadboard is difficult and they tend to fall out, but there is a method. So I always go across this little valley or divide, and let me just kind of line this up here. And I use my fingernails and really kind of jam that button in there. And there, it holds. That's my test, apparently fine. And so I'd want to put a wire here to connect on one leg. That's a little close together to there. And one there. Let's move this to a more reasonable spot. So that's what a button would look like. And now what we want to do, now that we have two wires to the button, is connected to the Arduino Uno. And how we're going to do this is one side of the button we're going to connect, let's use this one, to ground. It doesn't really matter. Then we'd connect that ground line to the ground of the Arduino. So let me do that. And then the other side of the button will be connected, let me get a longer wire here, to the pin we're going to use that we're connecting the button to. Let's say pin 3. That's right, yep. So that would be the basic formation of how we'd wire a button. Okay, and now let's take a look at a diagram of a button. So here we have a button connected to 5 volts. That's shown on the bottom of this diagram. and we have the button, and then the other leg of the button is connected to pin 3. So the button's open now. We haven't pressed it, so the pin 3 isn't connected to 5 volts. But when we press the button down, it is, right? There's a connection from 5 volts all the way to 3. Now, we've been using digital write. So digital write pin 3 high. That means send voltage out of pin 3 to light up an LED as an example. We can use digital read to do the opposite. So what voltage is coming into pin 3? So if 5 volts is coming into pin 3, it'll read high. So digital read 3 equals high. Let's convert the diagram to match what we have in reality, where we connected the wire, one leg of the button, to ground and the other to pin 3. That looks like this. The ground is on the bottom there. And when the button's open, not pressed, right, we don't have ground connected to pin 3. But when we do, so now ground is connected to pin 3, and if we do a digital read of that pin, it'll read low. So there's a way of checking whether the button is pressed or not pressed. All right, so we know when the button is pressed that it will read low. When the button is not pressed, it's not going to read low, because low means pin 3 is connected to ground, and it's not. And it's not going to read high, because high means pin 3 is connected to 5 volts, and it isn't. So it's in some indeterminate state. We don't know what it'll read. So we're unclear of what it's going to read, and we need to fix that. So either we can fix it by adding parts to our circuitry, which that's the approach we're not going to do, or we can do a software trick. So the Uno has some built-in circuitry that we can employ. And how that works is as follows. Normally, when we do a digital read, we say that pin mode is an input pin. So pin 3 is input, which in this case it is, right? It's going to read that button. If it was lighting an LED, it would be pin mode output. Instead of saying input, though, we're going to say input pull-up. And what that means is that if the button's not pressed, we're going to want that digital read to be high. Right? It's going to read high if it's not pressed and low if it is pressed. So with that simple software change, we can have a button that actually works. So we're going to set the button in setup with pin mode, whatever pin the button's connected to, input pull up. And when we want to read the button, we do digital read, and it'll tell us whether it's high or low. Low means the button's pressed. So when it's not pressed, it's going to read high. So we found a way to ask a question. So is the button pressed? And we do that by saying, is digital read 3 low? We'll look at the actual code in a minute. Right? This gets us to ask, or enables us to ask questions. So we can ask this question of, hey, is the button pressed? If so, do something. Blink a light. If it's not pressed, do something else. So we're on the journey of figuring out how to ask these questions about whether the button is pressed. And now we want to write code that when we press the button, let's say, an LED light will blink. So in English, something like, if button pressed, blink light, blink LED. So that's what we'd like to do in English. How can we implement that in code? Well, an if statement in the Arduino language is if. Then in parentheses, we're going to have something like, for now, let's just say if the button's pressed, we'll just say button pressed. We'll fix this later. Then everything we want to do if the button's pressed, we'll put in open and close braces. So we're going to blink the LED, and we know how to do that already. So now we have to figure out, well, how to do this button press. How do we ask a question using the Arduino? And the thing that's inside these parentheses has to be either true or false. That's it. Whatever we write here has to be true or false. And that isn't so odd, because in English, if statements work the same way. It has to be true or false. You just can't say, if your age, then you can come. Or if you're scoring the quiz, then you get an A. Or if your name, then you can come. Or even mathy things like if your weight divided by your height, then you get the vaccine. None of these make sense because in English, if works, or in any other language, this if requires that whatever's after it has to be true or false. So to go back to our first example, maybe it would be something like if your age is greater than 18, then you can come. Or if your name is on my list, then you can come. If your score on the quiz is greater than 90, then you get an A. If your weight divided by your height is whatever it is, then you get a vaccine. So whatever is in here in the parentheses in our code case has to be true or false. Now let's go back to coding. Okay, so let's see how if statements work with code. So here I am. Let me just create some variables. I'm following work to code. I'm going to create a wait, how much time the blinking will be. So we're trying to make a program that when we press the button, it'll blink. And I need a variable for the LED. So that's on 13, pin 13. And let's make one for the button that's on 3. All right, that looks pretty good. And now in setup. So we want to do pen mode. Let's set that LED to be an output, right? Because we're sending power to the pen. And that button will be, as we were talking about before, an input pull-up. Okay, and the loop, what we want to do is something like if button is pressed, then loop. Then loop, then blink. All right, that's what we want to do. And we said the if statement was sort of like if button pressed. We'll fix that in a second. Then here's where we're going to put our blink code. And let's fill that in because we should know how to do that. So we would do digital write LED high. So we turn the LED on. We delay that wait time. We do digital write. We turn off the LED. And we wait. So if the button's pressed, we're going to turn the LED on, wait, and turn it off and wait. All right, so now we need to concern ourselves with how do we check whether the button is pressed. And because the button is connected to ground and we have this pull up, when the button is not pressed, it's going to be high. And when the button is pressed, it'll indicate low. So let's get a variable set up for that. That'll be, let's call it button state. So it's an integer. And we can do that digital read of the button. Right, so it's either going to be, this is a comment, low, which means it's pressed, or high, means it's not pressed. Sweet. Okay. So we have a button state here, and now we want to check if it's pressed. And to ask a question, so with one equal sign, we're setting button state to be something, some value. When we have two equals signs in a row, it's asking a question. Is button state some value? It's going to something evaluate true or false. So if the button state is low, it means we press the button, so then we blink. So that's all we need to do. So let's give this a try. Let me upload it. Save it to not Arduino, but my Arduino course, experiment 2. And let's call it button try. I don't know. All right. And it's done uploading, and let's check if it works. So now the LED is off, and I press the button, and it blinks. So that works fine. So let's look at this. So if the button is not pressed, then we skip this whole section that is from here to here, and we don't have anything else after that. So that just stops there. So it's checking if the button is pressed. If it is pressed, it'll execute everything within those braces. Let's try something a little different. Suppose if the button's pressed, we want it to blink fast, like what we have, the wait time 200 milliseconds, and if the button is not pressed, we want it to blink slower, like once a second. So here we have the fast part. So if it's pressed, then we already have that code, we're blinking fast. Else we're going to execute everything within these braces. So it's the same bit here as here. So let me just do a copy paste. But this time we're going to wait 1 second. 1 second on, 1 second off. So it works like this. So if the button state is low, we're going to execute everything from here to here. And if the button state is not low, then we execute else. Else do this part here. Let me get rid of some spaces. All right, so what happens here is if the button's not pressed, it'll blink slowly, and if the button is pressed, it'll blink faster. So let's upload that. I'll call it the same thing, button try. We're just kind of experimenting around here. Now it's blinking slow, and if I press the button, it's blinking fast. Let me save this as something else just so we have a copy. Button try, but I'll call it 2. This isn't naming things very well, but we're going to go for it. All right, so let's look at a different idea. So this one here takes, I'm on line 25 here. Let's see if we can make a more efficient version of this, and we can. This isn't bad. This works perfectly fine, but let's look at what a different version might look like, just so we see some variety. And let's say it's this. So we say if button state is low, then we'll change the wait time to be 200. We want it to blink fast. Else, wait time is 1000. So if we press the button, we'll set the wait time to be 200, else we'll set the wait time to be 1000. Let me modify this material here. Let me line things up a little. Okay, and let's look at the logic here. So we check if the button is pressed. If it's pressed, we set wait time equals to 200. If it's pressed, we execute everything from here to here, and we skip this part here. We don't execute this else, right? We don't execute wait equals 100. And so we skip over it and start executing the lines after that. So we encounter this blink pattern. If the button is not pressed, so we skip this part, right? This only occurs if it's pressed. So we execute this part. This executes when the button is not pressed. That sets the wait to be 1000. And then we resume control immediately after it. So we do the digital write LED high, the wait, the LED low, and wait. So that's that approach. It looks a little better. Let me just kind of clean up the blank space. Let's clean up this space too. And we saved, even in this simple example, about 4 lines of code. So that's a little improvement, and I think it's a little bit more legible, although either approach would work. So let's make sure this works. Let's just upload it here. And let me test here. So it's blinking slowly, and I press, and it blinks fast. So that works fine as well. Okay, and let's try something more complex. Suppose we have 2 buttons. In my case, I have little top semi buttons. There's a green button and a red button. And if I press both of them, let's say it'll blink really fast, 100. If I press the red one, it'll blink at 200. If I press the green one by itself, it'll blink at 500. And if I don't have any pressed, it'll blink slowly at that 1 second. Whoa, that sounded kind of complex, but let's see if we can do it. I'm pretty sure we can. So instead of one button, so the button connected to 3 is the green button. So let me just rename that. And then I said I had a red button. It's connected to 4. And I need to add something to setup. And change the name of this one to green. Okay, that looks nice. All right, so now in addition to reading the green button state, maybe I should name these something a little shorter but still understandable. We're going to read the green button here. So that didn't change other than changing the name of the variable. So I have a green button. I'm going to read that green button, and it's going to read high or low, and whatever the value is, it's going to be inside green button state. Okay, and let's do this, same thing to the red button. All right, so we have the 2 buttons indicated. Now, if both are pressed, I wanted it to blink fast. I don't remember the speed. I think it might have been 100, but let's try that, if we can implement that. And we generally want to, when we make complex if statements, we're going to have the most complex part if statement first. So saying if both buttons are pressed, that's more complex than just saying one button pressed, because we have to say if the green button's pressed and the red button is pressed, and that's sort of a more complex, that's my terminology, if statement, than just saying if the red button is pressed. So we're going to put that more complex one, the most precise one, first. So I'm going to say if the green button state is low, and I need to bound all these in parentheses, you'll see shortly. And the AND statement in the Arduino and in many programming languages is those double ampersands. So if the green button state is low, and I think you could probably imagine what goes here, right? So what if green button state is low, meaning the green button is pressed, and we want to check if the red button is pressed. So that'd be red button state equals low. And here on this parentheses is bounding the whole part that's true or false. So we need this beginning one and end one here. So one part of this AND goes from here to here, right? If this is true and that is true, and then we bound that whole thing there. All right, so that was kind of a complex statement. Let's say I want to beat super fast at 100. That might be too fast. Else, okay, let's get rid of this so we can else, and let's just check if the red button is pressed, or the green button. Let's do the green button. Else if, now we know both aren't, at this point we know both aren't pressed. If both buttons were pressed, we'd be doing this up here and not executing an else. So by the time we get here, we know both buttons aren't pressed. So now I'm going to check if the green button is pressed. We already know the red button isn't. Let's say that's 200. Now we want to check if the red button is pressed. And let's say we wait equals 500. Now it doesn't matter, so we know that neither button are pressed, so then we can just say else. And there we wanted to just blink at 1,000, or 1 second on, 1 second off. So we say wait equals 1,000. And now let me take a look at this to see if I like it. And I think that looks good, although let me change the name of this so I don't lose the original. And let me call it, I don't know, 2 button speed. How's that sound? All right, now any bets on whether it works or not? So common in programming languages, or when I program, and I program a lot, most of the time I have some error in my code. So it's really common to have errors. I'm always surprised that it'll work. So let's give this a shot. And actually it worked. And I'm seeing it blink slowly. So let me press both buttons. And it's blinking super fast. Let me press the green button. And it goes to the next speed. And now the red button. The next slower speed, and no buttons. And it goes slower. So that seems to be successful. Well, should we make it a little more complex? Sure, why not? So again, things look complex. Don't worry, at some point this will start getting familiar with you. So it's expected that this is going to look more complex than the others and maybe slightly bewildering, but just work your way through it. The first time I encountered this, I probably had no clue what it meant. All right, so let's say instead what I want to do now is if the neither button are pressed, I don't want it to blink whatsoever. So I just want to check if nothing's pressed, I don't want to blink at all. So if both are pressed, I want to blink at 100. If the green, 200. If the red, 500. But otherwise, don't blink. So so I can leave this at 1,000, but I'm going to change it to 0 just for fun. There's no really reason for it. We're going to need another if statement. So this whole if statement goes all the way from here to here, right? So I got if this is true, then do this. Else if this is true, do this. Else if, else. And now we're done. So we know that no matter which of these conditions hold, we're going to execute the next line, just like we did here, right? So we knew it's going to execute one of these, and then these 4 lines will occur. It's going to blink. Now we only want it to blink if weight equals some value. So what is it? So if we say if weight equals what? So if it's, let's do that then. So I could say if weight larger than 0, that means we must have pressed the button. Then, and you can see I'm working the code because I didn't need to indent it, right? I could have not indented the line, but it just is more readable this way. So here I set the wait state, right? If both buttons are pressed, weight is 100. If the green button's pressed, weight is 200. If red is pressed, 500. Else, well, weight is 0. And here I check if weight is larger than 0. If we didn't press any buttons, it would be 0. We wouldn't be blinking. But otherwise, we're going to blink the lights. That looks good to me. And let's give that a shot. Okay, it's done uploading and nothing is blinking. So, hey, that's something. Now let me press both buttons. And it's blinking super fast. It's not blinking when nothing's up. Green button blinks slower. And the red button blinks even slower. So I think I've said enough of if this looks complex, it's going to look complex, and you'll get better at debugging all this and understanding it. So I'll just leave you with that. So I showed you the basic beginner button. You know, we have one button and we just have a simple if statement, but we're going to be constructing these more complex ones, right? So if something is true. And if you have questions, just ask. Just do a shout out on the Discord channel or message us, and we'll try to help you figure these things out. So thanks very much for watching this video. I hope this was helpful, and I hope the poodles were a little entertaining. It's always good to have some poodle content. Take care. Bye.